So now I'm going to explain BTech semester 1 M-1 mathematics NGNQ unit 2 eigenvalues and eigenvectors. So in this first, let A be a square matrix. A non-zero vector x is to be characteristic vector of A if there exists a scalar lambda such that Ax is equal to lambda x. So this can be written as lambda ix. I means identity matrix. So send this left side, plus will become minus. So in these two terms here x is there common, so a minus lambda I into x is equal to 0. This is known as homogeneous system with n unknowns, non-zero solutions. So in this, determinant of a minus lambda I is equal to 0 is called characteristic equation. So problems, this is very important in your semester. Find the eigenvalues and corresponding eigenvectors of the matrix 2 of this matrix. So let us assume A is equals to 3 by 3 square matrix. So the characteristic equation of lambda is A minus lambda I is equals to 0. So put lambda in place of diagonals. Subtract lambda in place of diagonals. 2 minus lambda 2, write this 0 as it is, write this 2 as it is. Here 5 minus lambda, here 0, here write the 0 as it is, 0 as it is. Here 3 minus lambda is equals to 0. So now multiply 2 minus lambda into 5 minus lambda into 3 minus lambda minus 0 into 0 is 0. So next, so determinant means here plus minus plus. So here minus 2 into 2 into 3 minus lambda minus 0 into 0. Next here 0 is there. So 0 into something is 0. No need to multiply. So write here 2 minus lambda as it is. So here first term into this total term. Again this second term minus lambda into this total term. Minus 2 into here multiply 2 inside. 2 into 3 is 6. Plus into minus is minus. 2 into lambda is 2 lambda is equal to 0. So here write 2 minus lambda as it is. Now here multiply 5 inside, 5 into 3 is 15. Plus into minus is minus. 5 into lambda is 5 lambda. Minus lambda into 3 is minus 3 lambda. Minus into minus is plus. Lambda into lambda, lambda square. Minus 2 into 6 is 12. Minus into minus plus. 2 into 2 lambda is 2 to the 4 lambda. So here write 2 minus lambda as it is, write 15 as it is. Minus 5 minus 3 is minus 8 lambda plus lambda square. Minus 12 lambda plus 4 lambda is equal to 0. Now multiply this first term with this total term, and again minus lambda second term with this total term, and write this as it is, minus 12 plus 4 lambda. So multiply 2 inside, 2 into 15 is 30. 2 into minus 8 is minus 16 lambda. 2 into lambda square is 2 lambda square. Minus lambda into 15 is minus 15 lambda. Minus into minus is plus. Lambda into 8 lambda is 8 lambda square. Minus into plus is minus. Lambda into lambda square is lambda power 3. Write these two terms as it is. Now write like powers in one side. So minus t power 3 plus lambda squares. So 2 lambda square plus 8 lambda square. Close the brackets plus lambda terms. Minus 16 lambda minus 15 lambda plus 4 lambda. Close the brackets plus constant bottom 30 minus 12. Write in one bracket is equal to 0. So lambda minus lambda power 3 plus 2 plus 8 is 10 lambda square. So minus 16 minus 15 is, write minus as it is and add these two numbers. 16 plus 15 is 31. Minus 31 lambda plus 4 lambda, write as it is. Here 30 minus 12 is 18. So write these first two terms as it is, minus 31 plus 4 is how much, minus 27 lambda plus 18, write as it is. So here write first two terms as it is, plus into minus is minus, write this 18 as it is. So here we can take minus common, if you are taking minus means minus will become plus. Here plus will become minus, minus will become plus, plus will become minus. So that only I have written over here. So this is a equation number 1. Now solve this equation. So by using remainder theorem, what put lambda is equals to 1. So here quotient of lambda cube is 1, right, as it is. Quotient of lambda square is minus 10. Quotient of lambda is 27. Constant term is minus 18. So let us assume lambda is equals to 1. Here write 0, 1 minus 0 is 1 plus 0 is 1. So here 1 ones are 1. So here minus 10 plus 1 is minus 9. So 1 into minus 9 is minus 9. 27 minus 9 is 18. So here 1 into 18 is 18. So minus 18 plus 18 is 0. Condition is satisfied. So now this third degree equation becomes a second degree equation in terms of lambda. So what we can write? Lambda square minus 9 lambda plus 18 is equals to 0. So it is in the form of a lambda square plus b lambda plus c is equals to 0. Here a is equals to how much? Quotient of lambda square is 1. B is equals to quotient of lambda is minus 9. C is equals to 18. That only I have written. So this process already you are studying your 10th standard and your intermediate. So a into c you should do. So 1 into 18 is 18. So 18 prime factors, 2 9s are 3 3s are. So in this only your result is 0. So we can take 2 3 are 6. Here 3. So minus 6 minus 3. If you are taking your b term is coming, sum of zeros terms. So minus 6 minus 3 is how much? Minus 9 coming. With same numbers, product also coming here. Minus 6 into minus 3 is how much? 18. So therefore this becomes, in place of minus 9 lambda, what we can write in place of minus 9? Minus 6 lambda minus 3 lambda. That only I have written. Minus 6 lambda minus 3 lambda, and first and last terms I wrote as it is. In first two terms take lambda common. If you are taking lambda common, so what you will get? Lambda minus 6. Here take minus 3 common. Minus will become plus, plus will become minus. So here lambda in 3 table 18 will come 6 times. In these two terms you are having lambda minus 6 is common. What are the remaining terms? Lambda minus 3. So lambda minus 6 is equal to 0. Lambda minus 3 is equal to 0. Send minus 6 that side, it will become plus 6. Send minus 3 that side, it will become plus 3. So 0 plus 6 is 6. 0 plus 3 is 3. So what are the eigenvalues you got? Eigenvalues are lambda is equal to 1, lambda is equal to 3, lambda is equal to 6. So 1, 3, 6. Now we will find eigenvectors for the 3 lambda values. Case 1. The eigenvectors corresponding to lambda is equal to 1 is given by formula a minus lambda lambda x is equal to 0. Lambda I into x is equal to 0. So in place of this already I have written here only this equation. Your determinant is there. Here I have written 3 by 3 matrix. Here x means x1 x2 x3 I am taking. Here 0 0 0. This is a homogeneous equation. So in place of lambda substitute 1 2 minus 1. This write as it is. Here in place of lambda write 1. So here also in place of lambda write 1. So here 2 minus 1 is 1. Here 5 minus 1 is 4. Here 3 minus 1 is 2. Rest all are remaining same. Now consider here 2x3. 2x3 is here 0x1, 0x2, 2x3. So 0x1 means not valid. 0x2 also not valid. So here 2x3. 2x3 is equal to 0. Send to that side. Multiplication will become division. 0 by 2 is 0. Now consider second row. Second row. 2x1 plus 4x2 is equal to 0. 2x1 plus 4x2 is equal to 0. In that I am taking x2 is equal to k. You can take x1 also, nothing, no problem. So 2x1 plus 4k is equal to 0. Send 4k that side, plus will become minus. 0 minus 4k is minus 4k. Send 2 that side, multiplication will become division. 2 1s are 2 2s are. So x1 is equal to how much? Minus 2k. So therefore we got eigenvectors. Eigenvectors corresponding to lambda is equal to 1 is x1, capital X1 is equal to what we have taken, x1, x2, x3. X1 value how much you got? Minus 2k. X2 value is k. X3 is 0. Now take k common, if you are taking k outside, what we can write? Minus 2. Here 1. Here 0 by k is nothing but 0 only. So minus 2, 1, 0. These are the this is the eigenvector corresponding to lambda is equal to 1. Now case 2. The eigenvector corresponding to lambda is equal to 3 is given by, so same equation, in place of this lambda you have to substitute 3. It means in diagonals, lambdas are there in diagonals. So 2 minus 3 is minus 1, rest always same. Here 5 minus 3 is 2, here 3 minus 3 is 0. See here, we got one row is 0 completely. So what we can write here? 2x1 plus 2x2. 2x1 plus 2x2 is equal to 0. So otherwise you can solve directly like this. Minus x1 plus 2x2 is equal to 0, and 2x1 plus 2x2 minus x1 plus 2x2 is equal to 0, and 2x1 plus 2x2 is equal to 0. Solve by directly. So here second equation plus there means minus, plus there means minus. Here both will gets cancelled. Here minus 1 minus 2, how much? Minus 3x1 is equal to 0. So in this multiplication minus that side, it will become division. 0 by minus 3 is 0. Now put x1 is equal to 0 in any equation, I am keeping in this equation minus x1 plus 2x2 equal to 0. X1 means 0. So minus 0 plus 2x2 equal to 0. So 2x2 equal to 0. Send to that side, multiplication will become division. 0 by 2 is 0. x2 equal to 0. And x3, here nothing is there, so keep x3 as some constant k. Therefore the eigenvector corresponding to lambda is equal to 3 is x2 is equal to x1, x2, x3. So x1 how much you got? 0. x2 is 0. x3 is k. Take k outside simply. 0 by k is 0. 0 by k is 0. Here 1. Next case 3, the eigenvector corresponding to lambda is equal to 6 is given by. So you see in place of same, in place of this lambda you should keep in diagonal 6. Rest all are same. So 2 minus 6 is minus 4. Here 5 minus 6 is minus 1. 3 minus 6 is minus 3. So now see here, direct. Minus 3 x3 is equal to 0 we can take. Send minus 3 that side, multiplication will become division. 0 by minus 3 is 0. Next in second row see here, what is it? 2x1 minus x2 is equal to 0. Let us assume x1 is equal to k. Then it becomes 2k minus x2 is equal to 0. Send 2k that side, plus will become minus. 0 minus 2k is minus 2k. Minus minus cancel. So x2 is equal to 2k. Therefore the eigenvector corresponding to lambda is equal to 6 is x3 is equal to, this is a condition we know, in that x1 is k, x2 is 2k, x3 is 0. Therefore x3 is equal to, you can take k common, so if you are taking k common means what we can write? 1, 2, 0. Here 1 we can write, here 2 we can write, here 0 by k is nothing but 0 only. So this is a important model, in your BTech. So next video I will tell some more problems.